One of my favorite things to do is save things from being scrapped. But I was too late on this one. This one was scrapped. Luckily, the guy that owned the scrapyard realized this had more value than just a lump of metal. So the scrapyard is where this video starts. Here's the place of the lathe. It's a scrap metal dealer. That's a serious drill press. This is a big shaper. The whole head slides back and forth over whatever you have in the vise here. And that is one serious vise. Here's another pile of machines. Those old Van Normans have a head you can rotate so you can either have vertical or horizontal. This is the one I'm after. Let's see if it still turns. Yep, it turns. Doesn't look like it's been outside for too long. I saved it, and then it followed me home. Made it here. Didn't even fall off the trailer. Now I have to figure out how to unload it. When I bought this, I didn't really look at it. I made sure the handles moved and it wasn't frozen up. At the price I paid, I wasn't going to question anything. Now I got it in the shop, I can take a closer look at it. But I'm not going to do that yet, because right now this thing is totally in my way, and I want to be able to move it around here. You may have noticed in previous videos, I've accumulated a lot of stuff, and I'm running out of space. Remember those games where they had one tile missing and you have to shuffle all the pieces around to get the order you want? This place is a life-size version of that. Every tile needs to be able to move, so that's the first step. I need what's sunk into the ground right here. This piece is long enough I can split it exactly in half and have just what I need. This piece has been used before and I gotta clean it up a little bit. There's weld beads along the side and they stick up a bit. There's a big one right down the center. Not sure what that was doing, but I gotta take it off because I want that surface pretty smooth. Ear protection. Forgot that part. Luckily it's the kind of thing you remember pretty quickly as soon as you hear it. The length was pretty easy because I only had that one piece and it's going to be close enough. On the width, a little over 26, I'm going to call it 27. Pick these caster wheels up at Tractor Supply. It says it's good for 800 pounds. We'll find out. Now I don't want anything protruding through, so I'm going to weld these on, and they're coated with some kind of plating. You never want to breathe that stuff. You can probably hear all the fans I got in the background. Need a little bit of clearance all around because these might deflect. I don't want them running into anything if they deflect. A little under a finger width here, a little under a finger width here. We should be good. I'm making some little braces that are going to go between the two pieces of channel. When doing stuff like this, it's important to actually measure the channel and where you want to put the brace, because sometimes these pieces of channel aren't straight. You don't want to be caught assuming the distance and then having to make tiny little sliver cuts afterwards to fix your mistake. That's fixed. This is all welded together. I'm ready to lay it down on the floor. But I noticed these wheels have grease fittings. They're there to make it easy to do maintenance, and as soon as I set this on the floor, I'm never going to maintain it again. So I'm going to grease them now and put a lot in and then completely ignore them for decades, possibly the rest of my life. Now it looks like I put these on in an asymmetric pattern. That's both a yes and a no. They're asymmetric now, but there is future symmetry. Because I spaced this wheel so I can put another set right there and have 8 evenly spaced across. But right now, I think I need most of them on one end. Because I picked up this unit from that point right there, which is not in the center. That end's heavier. That end is going to get the 4 wheels. In the future, if I ever need to do anything really heavy, I can add 2 more right there, and then this thing is good for 6,400 pounds, in theory. Let's see how well those things work. That's heavy. Made a lot of creaking sounds going up. That rolls easy right now. All the weight's on the cart now. I'm not unhooking that until I try rolling this a little bit. I've seen myself well. I don't trust him. I can move it. It definitely doesn't move easily, but it does move. When I push it, it just moves side to side a little bit. It doesn't actually rock at all. I think we might be okay here, which means we can actually start playing with the lathe itself. I got a data plate here that tells me something about the machine. This lathe was made by the Monarch Machine Tool Company in July of 1950. It's a Model 10EE, which will turn apart 12.5 inches diameter by 20 inches long. I went to the company's website, and they're still making that same machine today, 25 years later. It had to be a pretty good design. You saw when I got this, it had been sitting outside. There's some surface rust. And the first thing I'm going to do is coat this whole thing with a light oil. My go-to used to be WD-40 for this kind of thing. In theory, it displaces water, and I figure that's a good thing. But WD-40 has gotten expensive. Like 10 bucks a can last I looked. So, I'm going to try out the $3 Walmart can of lubricant. And basically, we're just going to spray paint the entire machine with it. There's a scroll inside the chuck. All that needs to move and be lubricated. Look at the way the rust is coming off this stuff. I'm just washing the machine with oil, and that'll get a lot of this rust right off. You can even wash down all the handles and knobs and everything. Not going to spray the tachometer though. You can get the tool post. It's got a nice little quick change on it. It didn't come with this tooling. My buddy Skipper hooked me up with it. I just wanted to make sure it fit. So I shoved it on there already. Everything's soaked in oil. That moves smooth. Cross slide. I'll have to figure out this double dial system. Moved it far enough to get to the screw, and that's going to get us soaking too. Now I'm going to start wiping down things, see how it really looks. That's not bad. Not perfect, but not bad. Definitely good enough. That's cleaning up good. The tailstock really didn't want to move. Takes quite a bit. The lock is free. You can see there is a lot of rust in there. So we're going to extend this out quite a bit and give it the usual bath. Get in there. Pretty much all these levers and knobs lock in place, but they all have some way to release them. The knobs, you pull them. Got this one moving too. I got it to wiggle a little bit, but not very far. You actually push the handle in order to move them. The oil's starting to creep out, so I know I got oil in there. This one I haven't got to move yet. So we're going to keep soaking it and fiddling with it. This one pulls, so some of them are different. Most of the stuff is starting to free up pretty easily. We're getting somewhere. We're going to do another round of soaking and leave it overnight. There we go. We're rolling. This thing should weigh under 4,000 pounds. That should hold 4,800. Holding and rolling nicely are apparently two different things. What we need to work on right now is this end. When I bought this machine, I knew it was supposed to have 3-phase. I don't have three-phase here. But this is three-phase. I just used a variable frequency drive. These boxes convert single-phase into three-phase and give you a speed control. Changing the frequency here changes the speed there. Hertz goes that speed. Up the frequency, we're back to full speed. That was quick and easy. So that was my plan. Until I looked in here. That is not a normal three-phase motor. The new ones are 7.5 horsepower, so it's a pretty big one. And that is an entire box to run it that is all meant for three-phase. And this little knob right here adjusts the speed of the motor. It goes through to that sprocket, which turns that chain, which then turns this unit, which gives you a variable resistance. They already have their own variable speed built into this. He calls it a motor generator. I found a manual, and that's a complicated unit. And I actually don't want to mess with that. Here at the Low Buck mine, I've got power. You can see by the one transformer, it's single phase. But look above it, there's 3 lines going to it. 2 of those don't hook to anything. I think that is three-phase power right here at the pole, right next to my building. Then I could use the machine as is. I don't want to modify or remove any of this stuff. Eventually I'll need it all. One thing about the lathe, it's one of the earliest type of machine tools. This type of machine was in use back when you had water wheels powering stuff. They had an overhead shaft and just ran a belt down to them. They're set up with all these drives and all these shafts that move everything are all driven from that spindle. I just need to turn this spindle and then everything works. I could run it off that thing if I geared it down enough. Move this tensioner out of the way. Get this tensioner out of the way. All I have to do is get this thing to spin. Grab the chuck key from my rotary table. Hopefully, oh, looks like the right size. Oh, this thing turns fine. It's soaked overnight in oil. Now works beautiful. Granted, I didn't try it before, but it works now, and now is what matters, because we're now. Hopefully it'll work for the future too. That's always handy. Let's chuck up a piece of whatever random stock we find. Add a cordless drill. Now this is going to have a lot of inertia, so you got to do this pretty gently. Oh, tachometer's up. Doing 200 RPM. Tabs turning. Automatic feed is going. We'll try the cross slide here. Cross slide is powering. That is a working lathe. It's just somewhat inconvenient to use because the drill is where your workpiece would be. So let's make it a little easier to use. This is a 2-speed 1725 or 1140 half horsepower. A little on the small side. Here's another one. Horsepower 1/2. There's one I used for a vent fan when this used to be my main garage. Let's see what this is. It's very rusty. I'm actually going to try out bolt cutters on a bolt. This will be a first. Perfect. And another 1/2 horsepower. This one's totally locked up too. But now I've got a mount for one of these. I went back to the first one I found. The mount's in the vise, motor's mounted to it. And I've got an old extension cord. It was a bad one, so I added some new ends on the other end. Let's see what happens. It works. And now the dust's out of it too. Now I need to go to my miscellaneous pulley pile. I actually used this one to pull out an axle the other day. And that's the right double groove to match the spindle, but I don't have enough power to need that. What I need is small, which are over here. Something like that. That looks like a little too small of a shaft. Something like that. That looks better. The one I found that looked like it was close enough is too big. The one that looked too small is too small. Luckily, too small is pretty easy to fix. Got the pulley on, and it looks like there's actually enough room in here. I can stack this motor on top of the old gearbox. This motor is significantly smaller than the old one, but by putting on the small pulley, it's also a lot lower geared. So the lathe won't go nearly as fast as it used to. The question is, can I still use it? Bungee cord to the old pulley might be totally fine. I want to make sure that it's really secure, so I'm going to wrap the bungee cord around twice. We're good. Let's see what happens. That is seriously low on power. But it is spinning it, gaining speed. We're running about 500 RPM. It's doing lathe things. Actually sounds nice and quiet. Bungee cord is working well. Wonder if I can turn something. I've got one of the used tools that came with the tool holder. A piece of tubing in here I can practice on. Well, that's doing better. I didn't even have to spin it by hand to get it going. Running our 500 RPM. I've got it set to some feed rate, not sure what one. We can go in 10 thou, flip the lever, and see what happens. It's making chips. Do another 10. Doing light cuts here, but I'm also holding the motor in with a bungee cord, so I figure that's about right. The finish is way better than anything I ever got with my old lathe. This is my old Craftsman lathe. They were pretty decent machines for a home shop type one, but very small. It's got a little bitty chuck, little bitty tooling. The tool post isn't very strong, it flexes quite a bit. The handles are tiny. It's got a tailstock. You can loosen a nut and slide this around. You can tell this is a high quality piece of equipment. Even the feel of all the handles and everything, it's just so much better made than my other one, which makes sense. My other one was made for a home shop user. This is made for a serious professional. Everything feels a lot more solid. The handles move beautifully. You can tell this is a well-made machine. Since it's tubing, I'm going to start in the center and move outwards. I've heard a few strange noises from here. I might have to fix this setup a little bit. It isn't attached except for the bungee cord. The belt is totally misaligned. It's rubbing here, it's rubbing there, and the extension cord's getting hot. I'm gonna do a little revision. Quite honestly, I'm surprised this worked as well as it did. I was expecting to have to upgrade it. I already had a plan. My original plan was this. This is an old electric truck. You've probably seen them at zoos and airports and all that kind of thing. I picked it up at a public surplus auction. I think it was $124 I paid. This is around a 4 horsepower electric motor with a belt drive. I was planning on using that motor in this lathe, but I don't think I need it. We'll save that for a future project. Maybe it should be 4x4. I don't know. A half horsepower is actually adequate for what I wanted to do here. When you're cutting, one of the critical factors is your surface speed, which is the speed the tool goes over the part. There's a lot of factors, but you can get a rough idea from a chart. In this case, I'm going to shoot for around 100. You use that surface speed of the diameter part to figure out your RPM. In the case of the 3/4 stuff I was working with, that 500 was spot on. But the part I really need to work on is this one. And this is bigger. When I go to something this big, I need to turn it a lot slower. I'm looking for going about 4 times as slow. Which means the setup I have is too fast. So I need to go slower and have more torque. Which means I need a lot more gear reduction. Which not only will make it go slower, it'll reduce the load of my motor. I'm going to shoot for around 3-4 to 1, somewhere around there. I'm going to have to add a shaft in here, another bigger pulley, and I think I can tuck the motor down here and everything should still fit back together. Let's see what I have in my parts piles. This is mostly chain stuff. I'd rather not go chain. Bearings, I need those. Probably too big. Ooh, 5/8. That looks perfect. And I got 2 of them. Then pulleys. That's the right diameter. That's for a water pump. Looks around 5/8 shaft. A little small, but it's worth a try. I'm stuck in position with the pulley driving the spindle because it has to line up with the pulley and the spindle. The other one can go to either side. This is only a 2-speed motor. I'm going to want to have more speeds than just 2. That pulley will be on the outside, so I can swap it out with different sizes real easy. I'm back in my pulley pile. I decided I don't like this one. It's really narrow. Those small diameter pulleys hold a much wider belt, and I wish it was a bigger diameter. I'm going to enter the pondering phase and think about this, and then do something else in the meantime. This machine has decades of buildup on it, giving it a kind of brownish, dirty appearance. I'm going to take some cleaner, an old Scotch pad, and then a rag, and see if I can make this look a little bit better. It's looking better, but now I can see where all the paint's missing, and the old coating of sanitarium green is showing through. I'm going to stop cleaning it and call it done. I'm to the point where I want to add the actual whey oil where it's supposed to go. The manual had a listing of all the areas to lube and what lube to use. They make some really good whey oils that are compatible with coolants and all that. And if you're in a production environment, it's worth it. But when you have a machine that you're only going to use once a month, and you're not going to use coolant that has to worry about mixing in contaminants, bar and chain oil works pretty well. It's nice and sticky. Just don't tell anyone who knows something about machining I did this. Not supposed to. I've used it, it works, and this stuff you can get anywhere. Try getting whey oil on a Sunday afternoon. Wow, this thing was pretty empty. Looks like it's been a while since anyone maintained this thing. You know, I'm going to put some directly on the wheys too, and all over the machine. It's been a long time since I had oil in it. And these machines like oil. Makes everything work better. A little messy, but I'm okay with that. That apron's still filling. Hasn't even hit the sight glass yet, and it's been a while. But while that's going, there's more sight glasses. There's one for the front bearing, one for the gears, one for the back bearing, all with different fill plugs. These call for hydraulic oil, which I've got 5-gallon buckets of. Now these fill through tiny, tiny little holes that you probably can't see. This is the tiny little spot where you're supposed to add the oil. Not a whole lot of room to work with there. I use these cheap measuring cups. You buy them in a set of 4 or whatever. First off, they're cheap. Secondly, I don't need to care about what I put in them because I can throw them away. And third, they got an interesting feature. You can pour through the normal spout, or you can turn it around. There's a gully here. I found this out the hard way one day when I accidentally tipped it back too far. You can line up the handle with your hole, tip it back slightly, and the fluid goes through the handle, and the handle guides it into the hole. It's a slow process, but anything that has a fill cap this tiny, it's going to be a slow process no matter what. But it's getting the job done. Good enough. You'll see it a little better filling this top one. It's a handy trick. I wish I had known it sooner. I got all the fluids topped up, and I came up with a plan for the drive system. The problem is I don't have all the parts, starting with a 5/8 inch diameter shaft. I couldn't find anywhere at all that sells it locally, particularly on a weekend. But I do have 3/4 inch bolts and a lathe. Have you ever seen these drill bits and thought they were funny looking and didn't know what they were for? This is what they're made for. We're just going to eyeball center here. Now we put the center drill into the center and make a center for the center. Now this machine had what's known as a live center on it. Basically it's a cone that has a bearing on it so it spins. They also make what's known as dead centers, which is a cone that doesn't spin, you just coat it with oil. The live center is better. That hole I just drilled goes on that cone. I can feel the whey oil, this is working really smooth. This thing is a pretty heavy piece of cast iron, and it just glides. Now we lock this unit down. This one has a lever. And then this handle advances the center into your part. I got the hex of the bolt in the chuck. We tighten that down. I'm gonna add a little more pressure on the center to make sure that bearing's in there nice. Lock this one down. And now our part is held rigidly on this end and on that end. Now to cut, we're gonna press the tool into the side. If it was just held on the end, the whole thing would wobble around. This gives it support, so that can't move anywhere. The thing is held nice and rigid. Not the right tool for the job, but I had it lying around. Seems to be working though. I upgraded my extension cord. Everything else is the same setup. Every once in a while the motor makes funny noises, but I'm ignoring them. So far it's working fine. I love the power feed. I can walk away from it and it's still working. I just have to come back before the end of that cut. Now, let's see how we did on size. Going for 5/8, so that's 0.6250. All right, that is 0.6258. It's about 1/1000th of an inch taper over the entire length. It's a tiny bit bigger on this end, which means this tailstock isn't perfectly in line with the spindle. It's this way a little bit, but there's adjustments for that. I can straighten it out later. I took off a couple thousandths more. A little undersized is okay, because I'm going for a slip fit anyway. It's hard to believe I found this machine in a scrapyard. Glad I did though. The finish is really good. This is definitely a rigid machine. Now, let's see if the pulley and bearings fit. It's tight, but it goes on. A little bit of wiggling. There we go. That is a nice fit. I am real happy with that. We just turned a bolt into a reduction shaft. Since I was having fun with the machine, I did some unnecessary stuff. Like doing a facing pass and adding a chamfer. One thing I can't do with the lathe is the keyway. I had to break out the milling machine for that one. Now it's 3/16 wide. I used a 3/16 end mill, but I did a second pass to make it a little wider because parts are rarely the size they're supposed to be. I want to make sure everything fits together easy. This is what's left of our bolt here. It's now much more shaft-like. I did leave the threads on the end. I might be able to use that to make a quick release pulley on the end here. I took the mount for the electric motor, welded a piece of tubing to the top. I put a new shaft in. I did pop for a new pulley because I didn't have the size I wanted. It's just a zinc cast one. It was pretty cheap. And the good thing about running this low horsepower stuff is that's totally fine. We got our bearings, we got our other pulley, we got our belt, and I bolted on a couple pieces of scrap angle. Ignore the fact they're two different size and thickness angles. It'll be fine. It was what was lying there. We put our belt in the pulley there. This is going to hang in this area. I'm about to attach the motor. One thing you want to notice, I don't know if you can see it there, there's actually one part that says belt pull. They want the belt to go in that direction to load the shaft one way. You don't see that in every motor, but if you do, you might as well do it. I drilled a hole through all these pieces so I can run a bolt through it, and that puts it on a pivot. Slide this whole unit in here, and it should fit. Now this whole shaft can pivot, so I can adjust the alignment and get my belt tension. Just need a belt for here. Now I've got a selection of used belts, and I tried a couple of them out. This one looks like it might do it. It's got some life left to it. A little on the tight side. That might work itself in. Someday I would need a better on switch here. The missing chunks of belt make a little bit of a clunking sound. I might look for another one later. Not really rubbing there anymore. Rubbing there a little bit, but we'll ignore that. That's on the slack side of the belt. As the pulley turns, it's pulling down on that side. Most of the force is on that side of the belt. It's really tense. That side's basically just returning. So that's the side that matters if it rubs. That side's not so big of a deal. A little under 100 RPM, which is what I was going for. I dug through the whole pile, got down to my last belt. There are quite a few of them, but I found one that works. I think we're all set here. Now wiring this is going to be pretty simple. Not sure about other countries, but in this country we use 3 wires for 110 AC. The black one's the real power, white is neutral, and green is a ground. As far as the motor goes, the neutral is connected to a common point. The live wire, as you can see in there, it's actually marked on the board, says high there. I had power fed straight to the high connection. Over here, you can see it says low. So if I want low speed, I put power to that. Neutral and ground always stay the same. I'm going to use a double throw switch. It's on, off, on. So we're going to put main power in here, and then we're going to have one feed to the high side, the other feed to the low side. So one switch will give me high and low and off. This switch is rated at 250 volts and 15 amps. This thing uses 115 volts. High speed is 8.4 amps, low speed is 4 amps. So we got plenty of margin of safety with this thing. Got my wiring done. Right now it's off. High. Low. All set. I didn't want to modify the case of this thing at all, and I didn't. In fact, the entire framework I made here isn't actually attached to the machine in any way. I didn't drill any holes, I didn't bolt anything. Basically, it's just crammed in there. With that long bar vertically, it can't really move a whole lot. And then the belts kind of hold it in place. And then, since it worked so well before, I got that bungee cord holding it backwards just for extra security. So this machine's totally unmodified. If I want to get rid of this, I unplug it, take off the belt, pull it out, it's done. There's nothing changed in the machine at all. This pulley gives me the right speed for the large diameter stuff. I still can do the small stuff, but it'll be slower. But all I have to do is undo this nut, swap out the pulley, and I'm back to a faster speed. So that motor will give me 2 speeds. Different pulleys will give me more. It's not as nice as the original dial that just changes the speed, but I'm not doing this every day. It'll work for what I need it for. I did have one problem though. I went to put on the end cover. I can't actually close it all the way because the nut on the end of that shaft would hit this little grate thing. But that's actually a problemtunity. If I was able to get that on all the way, I wouldn't have anywhere to run my wires. There's now other holes in the end here. So I'm going to leave it most of the way closed. That'll be perfect. Top cover should fit. The covers don't fit perfect, but they're on there and they keep people's hands out of the belts. My on-off switch is conveniently floating around wherever I want it. Someday I might make a mount for it. But right now, I have a lathe that's all together and just turns on with the flip of a switch. So let's make a part. Luckily these jaws bolt on and just fit on a key there, so you can flip them around to do bigger stuff. I used some spare pieces of key stock to space it out a little bit. That way, when I go all the way through, I won't have my boring bar hit the jaws. We'll tighten this thing down. Now we can remove that key stock. Otherwise it's going to go flying at some point when we weren't expecting it. And now I can get to my forklift part. Minor problem with this tool post where it is. That vice jaw. That's a bit of an issue. Luckily this whole post is on a T-slot, so I can just loosen up that nut and slide it over. You can slide this around wherever you want, rotate it, do all sorts of fun things. Somewhere around there looks good. That'll just barely clear. But just barely is still clearing. It's not like this thing is going to flex much. We're pretty close to the final size. I gotta take off a little more. I'm going for 1/1000 depth of cut. I can take off just a tiny little bit if I want to. This will get me a good fit. That is a finish I'm happy with. It's real smooth. Let's see if my bearing fits. That is exactly the light press fit I need. That fits that bearing perfect. Well, that's the end of this video. I still have to finish up my roller, but you'll see that in the forklift video when I actually install this. For now, I'm calling this one a total win. For a lathe that had actually been scrapped and was sitting in a scrapyard outside, now it's a nice precise machine. I can plug it in anywhere. Running off that little motor, it draws less than 9 amps. That's like 2/3 a hair dryer. I could roll this into the house and plug it into a kitchen outlet. Probably would get in trouble for that, but I could do it. It'll run off an extension cord wherever. I was talking earlier about hooking up a 3-phase power. I'm not even sure if I want to do that. Right now it's on wheels with a plug. I can put this anywhere in the shop at any time, just move it around as needed. I was really surprised to see how well that little motor did. It does everything I want to fine. I'm not doing production work. If you needed to go fast, this wouldn't be enough power. But for home use, it works pretty well. And it was a lot of fun to get this thing going again. I love resurrecting old equipment. Hope you guys are having fun too, and we'll see you next time.